In this video, I'll be demonstrating how to perform a one-way ANCOVA. And as we look at the data here in Intellectus, we see we've got 3 columns. So we have a group designation, which is our independent variable, and we have 2 numeric variables here. So what we're trying to do is determine if membership in a certain type of teaching group has an effect on exam score in a course. But we also want to examine and determine if the grade someone has in a prerequisite course for the course that we're examining here is a covariate for, has an effect on the dependent variable of the final exam in the current course. So we randomly assign people to 3 different types of instructional type. We've got lecture, we've got a blended model, and we have an online model. And each of the students was given a final exam. And this is percentage correct on that final exam. And then the potential covariate variable that we have is grade in the prerequisite course for the current course. So we want to still examine the differences among the 3 groups on our dependent variable, which is our exam 1 score, while accounting for or controlling for the potential of the covariate of the prerequisite grade. So this is how the data will be arranged. Now, in order to determine do some basic screening to determine if prerequisite grade is an actual covariate. One of the simplest ways we have of doing that is determining if the dependent variable, in this case exam score, and our potential covariate, in this case prerequisite score, are statistically correlated. So what we can do first in our first analysis is do a Pearson correlation to determine if these 2 variables are actually correlated. They cannot be affecting one another. In other words, the covariate cannot affect the outcome unless they are related to one another. So we want to verify that this is a potential covariate. So in order to do that, we want to look for a statistically significant correlation between our 2 variables. In this case, here's our outcome, exam 1, and here's our potential covariate, in this case, prerequisite grade. So we click confirm. And we go ahead and calculate that Pearson correlation. And if we skip down here to the results table, we can see that there is a correlation, a Pearson value of 0.50. And if we look at the p-value, we can see that is a statistically significant correlation between the 2. So this indicates to us on a basic level that our potential covariate prerequisite grade is related to the outcome and therefore could be affecting the outcome. And so we know now that this is an appropriate covariate that we can include in our analysis in order to take out or account for the effect the prerequisite grade has on the final exam grade, regardless of what group the subject may be in. So now let's go ahead and run our actual ANCOVA. So in order to do that, we're going to go back to the Analyses menu. We're going to go to the ANOVA menu, and you can see the second option down is ANCOVA. And so when you can see as I hover over this, the description of what an ANCOVA does, it's essentially an ANOVA. We're looking to compare multiple groups on a single outcome while we're controlling for the effects of an additional variable. Okay, so we're going to click on the ANCOVA option. And we can see here we first want to enter our dependent variable. So we add that, and in this case we've got 2 options, but we know that exam 1 is our dependent variable. So we confirm that. We next want to add our independent variable. And again, you can do multiple independent variables with ANCOVA, so you could have a factorial ANCOVA. But in this case, we just have 1 independent variable, and that's group. And we've got 3 levels in this particular independent variable. So we click confirm. And then lastly, we want to add our covariate. So we click on add modify, and we want to use prerequisite grade as our covariate. You can have multiple covariates as long as they kind of meet those basic assumptions of being correlated with the outcome. So we can do a multiple covariate type of analysis as well as a multiple independent variable analysis. So we've selected our covariate, we click confirm, okay, and then we click calculate. So we're going to go to the raw output and take a look at some things here. So one of the first things we want to look at, there's a couple of assumptions that we have when we do ANCOVA. One of the first ones, like with all ANOVAs, is that our outcome is normally distributed. And I went ahead and screened for normality before I did this, so I'm assured of the fact that our outcome is normally distributed, so it makes it appropriate for an ANOVA. The next thing I want to do is look at what's called the homogeneity of regression slopes. And one of the assumptions here is that, as we talked about previously, an ANCOVA essentially uses a regression to predict the effect the covariate has on the outcome. So we want to make sure that the regression slopes in predicting the effect of the covariate is equal among or similar among all three groups. And so what we look for here is the p-value here. And if this p-value is greater than 0.05, then we have met the assumption of homogeneity of regression. The next thing we want to look at is making sure that the covariate and the independent variable are independent of one another. In other words, we don't want to see that there's a pattern between the group you are in and the level of covariate that you have. So if that's the case, then there might be some bias in how people were assigned to groups, or some kind of bias within the groups, and some sort of potential bias in the covariate itself that interacts with the group membership. And so we want the covariate and the independent variable to be independent of one another. In other words, there's no pattern in what group you're in and what level of covariate you have. And so what we look for here is the p-value. And again, if this is greater than 0.05, then we know we have met the assumption of covariate independent variable independence, which is what we want to see. So in this case, we've met both of the assumptions for ANCOVA, which are unique to ANCOVA, and that is the homogeneity of regression and the covariate independent variable independence. Now, if we violated either of those assumptions, could we still do an ANCOVA? Yes, we could, but we need to then account for the fact, or at least identify the fact, that we violated some assumptions, and so that could then potentially introduce some type 1 error in how we determine whether or not we're seeing true statistical significance, or if there's some error that might be creating a type 1 error if we're rejecting the null hypothesis. So you can still do the ANCOVA, but you need to acknowledge the fact that we violated one or potentially both of these particular assumptions. Okay, the next step is to look at the effect of the prerequisite grade on the outcome. And so again, we're going to look at the p-value to do that. And we can see here prerequisite grade, this second row down, we can see that the prerequisite grade had a statistically significant effect on the outcome of the exam score because this value is less than 0.05. Okay, so that means that prerequisite grade did have an effect on the outcome, and so now the ANCOVA can account for that, and it's actually going to change the group means to account for the effect of the covariate. It's going to use a regression model to predict the effect that the prerequisite grade actually had on the final grade. So that's good. That means we picked a covariate that was appropriate. And so prerequisite grade is having an effect on the outcome, so we should be glad that we picked that, because that will now make our ANOVA omnibus test more precise. So if we look at the row just above that where it says group, this is going to tell us if there's a statistically significant difference between our three groups of instruction. And you can see here the p-value is less than 0.05. So there are statistically significant differences among our three groups. Now, which three groups? I don't know yet. We have to look at the post hocs to determine that. But there is a statistically significant omnibus test that's occurred here. And we can also look at the effect sizes here. Our partial auto squared, 0.24, which is considered to be a strong or large magnitude of effect. So not only are we seeing differences here, we're seeing large differences in their magnitude. Okay, the next thing we can look at is the marginal means table, which this is the adjusted means for the effect of the covariate. And we can see here that there are some differences among our three means. The online group seems to have a lower mean than our other two groups, and the lecture and blended groups seem to have very similar marginal means. And so again, that's the corrected mean for the influence of the covariate. Okay, the last thing we can do is try and find which pairwise differences there might be. So here's our post hoc test. Again, we're using the Tukey comparison to look for these differences, and we can look for each of these in a pairwise manner. So we can look at the lecture versus blended, and we can see that there is no significant difference between those two groups. The p-value is greater than 0.05. If we look at lecture versus online, we can see, again, there is a statistically significant difference here, less than 0.05. And then between blended and online, we can again see a close to significant difference, but just above. So we got 0.07, which is just above 0.05. So we would say that's trending towards significance, but not clearly statistically significant. So the only null hypothesis we can reject with any confidence comparing the two groups would be the lecture versus the online group. And again, if we go back to the means, we can see the lecture group had a marginal mean of 87, and the online group had a marginal mean of 77. So that's where our statistically significant difference falls. And so one other thing we can look at as we go to our interpreted output is we can scroll down and we can see our means with 95% confidence interval bars. And we can see here that the means are different, but if we look closely at the 95% confidence bars, we can see there is some overlap, certainly between the lecture and the online. There is some overlap between the confidence interval bars. It looks pretty close here with the blended group, but that kind of reduces our capability of seeing clinical significance because it looks like we do have some overlap with the error bars there, or the 95% confidence bars. So in conclusion, we can say that the group membership does have an effect on your final exam score, with, it appears, the blended group having a significantly higher score than the online group. The lecture and blended group, no different. And then the lecture and online group, it's close to significance, but it has not reached statistical significance. The effect size is large, so there's a large magnitude of effect, but that is mitigated somewhat by the fact that our 95% confidence intervals for the group means do appear to have some overlap, and so that reduces the clinical significance of this. We can also see we have some fairly small group sizes here, and so that could be having an effect as well in our ability to see the statistical significance. So hopefully you found this video useful, and good luck using this in your own research.